The connection made over the web is stateless. The website accepts all requests and responds to them. That is, unless something special is done to keep track, every request coming in to a Java server page or servlet is brand new and has no previous history. So if the state is important to your application, it's a matter of the servlet or the JSP keeping track of who's who. But the requests from one user may be intermingled with those of another. In fact, a number of users can have all their requests jumbled in among one another. Fortunately, there are ways of keeping this all straight and making certain that your servlet doesn't get itself tangled up. You need to make certain that your servlet stays thread safe. The problem simply is this. Right in the middle of executing a method for one client, there could be a context switch, and the same method could be called for another client. If the method stores data in a global location, that is a variable that is outside of any method, the value of the data from the two users could get mixed up. All Java classes are thread safe by the very design of Java itself, but you have to be careful that you do things to let them stay that way. The solution for this is to only use variables that are declared inside a method. You can use global variables if their value never changes, but changing variables should all be local. If you do this throughout, you don't need to do anything else. Two clients can be executing the same method, but they'll be using different variables because they're in different threads. There is an interface named Single Thread Model. If your servlet implements this interface, the system will guarantee that only one client at a time executes inside the servlet. But it has some disadvantages. If your website gets busy, only one user at a time is allowed access to the servlet, so it can slow things down, and this may not be a good idea. You can synchronize blocks of code so only one client at a time is allowed in that block. This doesn't solve everything, but it can solve some of these special situations. Don't synchronize large blocks of code or you're right back to that slow execution situation you get with the single thread model interface. If you watch how you use your variables, thread problems mostly come from accessing outside resources. For example, your servlet could be adding information to a file. This needs to be done one at a time, so you should synchronize the code that opens the file, writes to it, and then closes the file. This sequence needs to complete before someone else tries it, so this is a perfect place to synchronize code. But the problem comes up how to keep track of individual clients. There's good news here. It's done for you. I mentioned this before with Java server pages, and the same is true for the servlets. You have a unique HTTP session object associated with every client. It comes into your application with a request object, and you can retrieve it with a call to the getSession method. This is the same object for the entire session. Every servlet will return the same session object for the same client, and you can use the setAttributes method to store things in the session object, and you can use the getAttributes method to retrieve them. If you have some value, such as the user name or whatever, that you need to store someplace and have it persist from one request to the next, this is the place to put it. The system will keep one of these objects for each client. If you never request one, it never comes into existence, but once you have one, it stays. If the client accepts cookies, the session object uses a cookie for identification. If the client doesn't accept cookies, it has another method involving the URL of the client. Of course, this object doesn't hang around forever. It eventually goes away. This is done with a timer. After a certain period of time, if the session object is not requested by a servlet, it simply vanishes. It has methods named getMaxInActiveInterval and setMaxInActiveInterval that can be used by your servlet to read and set the amount of time before the session object disappears. I tried to come up with an example program to demonstrate all this, but by the time I had enough stuff in it that would do something with multiple sessions and then activated more than one session, the complexities of everything else hid the way it worked. It's very simple. Just take my word for it. It works. I promise.